You know when you're sitting on a plane looking out the window at that giant engine pod hanging off the wing, and you just kind of wonder, what is actually happening in there? Well, today we're going to pull back the curtain and demystify the incredible machine that makes modern flight even possible. All right, let's get into it. And believe it or not, the whole thing starts with a rule you probably learned way back in science class. Yeah, this one simple, really elegant law from Sir Isaac Newton is the secret sauce behind all jet propulsion. It's the one fundamental principle that makes everything else we're about to talk about work. So here's our game plan. First, we'll tackle that simple rule of thrust. Then we'll get right into the engine's beating heart. After that, we're going to follow the air on its wild ride, squeeze, burn, and blow. We'll also see how you can take one core and build many different kinds of engines. And finally, we'll touch on the ideal versus what happens in the real world. Okay, so how does that famous law actually apply to a jet engine? Well, it's actually incredibly simple and direct. I mean, that's really it. That is the entire idea in a nutshell. The action is the engine just chucking a massive amount of air backwards at super high speed. The equal and opposite reaction, well, that's the engine and the whole plane getting shoved forward. That forward shove, that's what we call thrust. Okay, so the big question is, how does an engine actually do that? How does it throw all that air backwards? To get that, we have to look deep inside at its core. And here's the really cool part. Pretty much every gas turbine engine out there, whether it's on a fighter jet, a massive airliner, or even a helicopter, they all share the same basic piece of tech right at their center. And this is the absolute key to everything. If you can wrap your head around what a gas generator is, you've basically cracked the code for how any jet engine works. You can think of it as the power-producing heart, and everything else is just built around it. So what exactly is a gas generator? Well, its one and only mission in life is to create a nonstop, powerful blast of super hot, high-pressure gas. That's it. And it uses three key components to pull this off: a compressor, a combustor, and a turbine. To really see how they all work together, we've got to follow a little particle of air as it makes its way through. All right, so let's imagine we can shrink down and follow a single particle of air as it gets sucked in for a pretty wild ride through the engine's core. The whole thing boils down to this incredibly powerful three-step dance: squeeze, burn, and blow. It's really that simple. First, squeeze. The air gets sucked in, and the compressor, which is like a series of fans, squeezes it down to insane pressures. Next up, burn. That super compressed air is funneled into the combustor, mixed with jet fuel, and bam, it's ignited. This isn't a single explosion, it's a continuous roaring fire. And finally, blow. That incredibly hot, expanding gas has to go somewhere, so it blasts out the back. On its way out, it screams through the turbine, spinning it like a pinwheel. And here's the genius part: that spinning turbine is connected back to the front, and it's what provides the power to run the compressor. It's a perfect, self-sustaining loop. So once you've got this amazing self-powering heart, the gas generator, you can start getting creative. You can use the power it creates in a bunch of different ways. And that's exactly how we get all the different types of jet engines, from the screaming turbojets on old fighter planes to the massive, quiet engines on the airliner you flew on last. Let's look at the two big ones. A turbojet is the simplest design. Basically, all of its thrust comes from that fiery hot gas blasting out the back of the gas generator. It's pure, raw power. But man, it is not very fuel efficient. Then you have the turbofan, and this is the game changer you see on pretty much every commercial plane today. What's the difference? It sticks a huge fan on the very front. Now, the gas generator's main job isn't just to push the plane forward, but to provide the power to spin that massive fan. And here's the trick: that fan pushes a colossal amount of air around the hot core. Believe it or not, most of the plane's thrust comes from all that bypassed cold air, not the hot jet exhaust from the middle. And that brings us to a super important idea in the world of jet engines: the bypass ratio. It sounds technical, but it's a really simple concept. It's just the ratio of how much air gets pushed around the core versus how much air goes through the core. And the numbers here are just mind-boggling. In a typical modern engine on a big airliner, for every 1 pound of air that goes through that hot, fiery core, something like 10 pounds of air are pushed around the outside by that giant fan. That's a 10-to-1 ratio. This high bypass is the absolute secret to why modern planes are so fuel efficient. It all comes down to a simple bit of physics. It's just way more efficient to move a huge amount of air slowly than it is to move a tiny amount of air super, super fast. Okay, so far we've kind of been living in a perfect world, right? We've been talking about the ideal engine, where everything works exactly as it should on paper. But as any engineer on the planet will tell you, the real world, well, it's a whole lot messier. So are real engines perfect? Ha, not even close. The truth is, every single step in that squeeze, burn, blow process has inefficiencies and losses. Yeah, on paper, in theory, an ideal engine is 100% efficient. But a real engine is in a constant battle. It's fighting against friction from all those moving parts, it's losing heat where it shouldn't be, the airflow gets turbulent and messy, the fuel doesn't always burn perfectly. You get the idea. And really, this is the whole story of jet engine development. The entire quest for the last 80 years has been this epic battle to fight those losses, to shave off percentage points of inefficiency, and to get the real-world machine as close as humanly possible to that perfect, ideal engine. And there you have it. When you boil it all down, the magic of a jet engine all starts with a super simple principle from Isaac Newton. But turning that simple idea into reality, that requires this incredibly complex, beautifully engineered machine that's constantly performing this dance of squeezing, burning, and blowing air, all while battling the laws of physics every step of the way. I mean, think about it. In less than a human lifetime, we went from the very first sputtering jet engines in the 1930s to the unbelievable marvels of efficiency and power we have today. They have totally revolutionized our world. It really makes you stop and wonder, right? What's next? What's the technology that's going to power our future and define the next 100 years of flight?